This video talks about friction. Consider a body of mass m at rest on a horizontal table. The force of gravity mg is cancelled by the normal reaction force N of the table. Now suppose a force F is applied horizontally to the body. We know from experience that a small applied force may not be enough to move the body. But if the applied force F were the only external force on the body, it must move with acceleration F by m, however small. Clearly, the body remains at rest because some other force comes into play in the horizontal direction and opposes the applied force F, resulting in zero net force on the body. This force, Fs, parallel to the surface of the body in contact with the table, is known as frictional force, or simply friction. The subscript stands for static friction to distinguish it from kinetic friction Fk. Note that the static friction does not exist by itself. When there is no applied force, there is no static friction. It comes into play the moment there is an applied force. As the applied force F increases, Fs also increases, remaining equal and opposite to the applied force up to a certain limit, keeping the body at rest. Hence, it is called static friction. Static friction opposes impending motion. The term impending motion means motion that would take place, but does not actually take place under the applied force if the friction were absent. As the applied force exceeds a certain limit, the body begins to move. It is found experimentally that the limiting value of the static friction, which is Fs max, is independent of the area of contact and varies with the normal force N approximately as Fs max is equal to mu s into N, where mu s is a constant of proportionality depending on the nature of the surfaces in contact. The constant mu s is called coefficient of static friction. The law of static friction may be thus written as Fs is less than or equal to mu s into N. If the applied force F exceeds Fs max, the body begins to slide on the surface. It is found experimentally that when relative motion has started, the frictional force decreases from the static maximum value Fx max. Frictional force that opposes relative motion between surfaces in contact is called kinetic or sliding friction and is denoted by Fk. Kinetic friction, like static friction, is found to be independent of the area of contact. Further, it is nearly independent of the velocity. It satisfies a law similar to that for static friction. Fk is equal to mu k into N, where mu k is the coefficient of kinetic friction, which depends only on the surfaces in contact. Experiments show that mu k is less than mu s. When relative motion has begun, the acceleration of the body according to the second law is F minus Fk by m. For a body moving with constant velocity, F is equal to Fk. If the applied force on the body is removed, its acceleration is minus Fk by m and it eventually comes to a stop. Thus, when two bodies are in contact, each of them experiences a contact force by the other. Friction, by definition, is the component of the contact force parallel to the surfaces in contact, which opposes impending or actual relative motion between the two surfaces. Note that it is not motion, but relative motion that the frictional force opposes. Consider a box lying in the compartment of a train that is accelerating. If the box is stationary relative to the train, it is in fact accelerating along with the train. What forces cause the acceleration of the box? Clearly, the only conceivable force in the horizontal direction is the force of friction. If there was no friction, the floor of the train would slip by and the box would remain at its initial position due to inertia and hit the backside of the train. This impending relative motion is opposed by the static friction Fs. Static friction provides the same acceleration to the box as that of the train, keeping it stationary relative to the train.